basically like adding on and like building this out and making it more difficult. So let's start off and kind of talk about what we're going to need. So we have our z-score formula. And our z-score formula, we have our x minus our mean divided by our standard deviation. So what I want to do is let's make a list of those quantities or those values that we think that we might have from this problem. And if I'm using different symbols, so this is our z, this is our data value x, this is our mean, and that is our standard deviation. And so when we read this, it says our mean is 20.7. So I'm going to go ahead and put 20.7 right there. It says that we want to be above 29. So 29 is going to be our x. And it says find the standard deviation. So we're looking for this. So somehow we should be able to find the z. So let's draw a quick sketch of what we're actually looking at here. So what this problem is saying is I want to know the probability that my z-score is greater than, I got that wrong. Let me hit pause real quick. No, that's right. I want to know the probability of my z-score, and I don't know what that z-score is. That's that unknown, right? One of the unknowns is greater than 4%, which is also known as 0.04. So when we look at this on our normal distribution, remember that when we take a look, the idea here is that we've got this like bell curve, and apologize my drawing. And right here, this is going to be a z-score of equal to 0. And we look at probabilities. So when we say we want to know the probability of 4%, that means that we're looking for this area right here. So this area right here would be 4%, which is also equal to 0.04. So what we would do is that we would take our tables and we take a look at our tables. So now to kind of understand what these are saying here is that this table right here is saying from 0 to z. So that's from 0 out to z. So if we did 0 out to z, that would actually be this area right here. So 0 out to z, let's see what color I have. Let's go purple. So this table right here would be looking at a normal distribution. Sorry about that. And let's say that our z-score was right here. Okay, this table would be telling us the probability of that area. Well, that's not what we're looking for, but we could use this table. So in the tutorials, they might use that table, because the way we'd use that is that we know that the distance from this guy right here from 0 out to the end is 0.5 or 50%. So if we found the area right here, we could say, and let's just call that area A, capital A. So if we took 0.5 minus our A, then we'd end up with actually what we're looking for. We'd actually end up with that area right here on the outside. And so we could use that table. Let's take a look at the next one. This table right here would be going from negative infinity to negative z. So this table would go, and that's this one. This table goes from negative infinity to negative z. So remember, this is 0. This would be negative z down here. And I'm sorry, excuse me, that'd be negative infinity. Let's go with that. Let's go eraser. And so that'd be negative infinity down there. So that would be like from here to there. That would be a negative z. So we could actually use this table exactly the same way that's used here. It's on the other side. But remember, a normal distribution is symmetrical. So whatever area I get right here is going to be exactly the same as the area, I'm going to change colors of blue, as the area that I'd have right here. And so that negative z-score would just become a positive z-score, and then we would use that. So I'm going to use this table because to me that's the easiest one to understand. And then I'll say a couple more things once I get into that. Okay, so now you're like, well, whoa, wait, what are we doing with all this? Why do you explain all that stuff with the table? Okay, let's get into that. So I explained all that stuff to the table because we have this 0.04. That's my probability. So when I open up this table and I start scanning through this table, what I see is that these are the probabilities. So that 0.04 is going to fall on this table right here. So as I start scrolling down, so right here I'm at 0.033. All right, that's not exactly 0.04, so I keep going. 0.034. So that 4 doesn't round to 3. Okay, here I get 0.035. So that 5 does round the 4 up, but there's a closer one. There's 0.0359. Okay, well, that's still, I got more over here. So 0.036, 0.0375, 0.0384, 0.03892, 0.40401. So now we've gone over. So that quantity right there has gone over our percentage. We don't want to overestimate our percentage. We want to underestimate. So we're going to use this guy right here. So I'm going to change back to my pen real quick. So I'll go back to my pen and let's go. We're using blue because that was our color. So remember, we found out that we had this guy right here, that if we round that, if we take, which is approximately equal to 0.0392, which we round that up and round up to 0.04. So from that, we go out and we grab our z-score. All right, so that means that our corresponding z-score for that percentage would be negative 1.76. However, that would be this z-score right here, that z-score. We want the other side, the symmetrical one. So what we're going to do is we're going to drop that negative and we're going to go with z is equal to 1.76. So what we've done is we found out that our z value for that location right there is 1.76 standard deviations above the mean. So now we can go back and plug that into, now we know our z-score is 1.76. Now we can do some algebra. So some good old algebra. All right, so now we've got our formula. So I'm taking my z-score right here. My z-score formula, I'm going to plug in what I know. So I know 1.76 is equal to, that's my z, my x, which is 29, minus my mean, which is 20.7, divided by what I don't know, which is my standard deviation, which is what I'm looking for. Okay, please excuse my dear Aunt Sally. Going in reverse in algebra, I'm going to go ahead and combine the subtraction real quickly. So I get 1.76 is equal to, I got my calculator out. I'm taking 29, take away 20.7. I get 8.3 divided by my standard deviation. And now at this point, it really depends on like where you are with your comfort with algebra. I'm going to go ahead and do cross multiplication to do this. So I'm going to take those two and multiply. So I take 1 times 8.3, I get 8.3. And then I'm going to take 7.6 times pi, and I'm going to get 1.76, not pi, excuse me, standard deviation. All right, so that was cross multiplication. Now I've got myself a nice linear equation. So the inverse of multiplying, I'm trying to solve for standard deviation. The inverse of multiplying is to divide. So I'm going to divide this side by 1.76. If I do something to one side, I have to do it to the other. So my final solution for this guy is going to be, those cancel. Standard deviation is equal to, pull up my calculator again, 8.3 divided by 1.76 is equal to 4.7159 dot dot dot. When I go back and read this question, let me change back to my mouse. When I go back and read this question, it says, with a bunch of writing, round your answer to the nearest tenth. So when I do that, I get all this stuff here. I've got my approximate final solution is going to be 4.7. So I come up here,